Today we're looking at identities. There's a lot of reasons why we need to simplify different expressions in terms of sine and cos, but in general, you just want to make sure you understand how to do all of the changes. So we have the basic reciprocal identities and a couple of the quotient identities. Now, we also have these three Pythagorean identities that are based on the Pythagorean theorem that says that x squared plus y squared equals radius squared, or hypotenuse squared, for the unit circle. And without having to develop these other two for tan and cotan, we're just going to accept them as they are. And there are variations on these where you can isolate different parts of them by bringing the one over to the other side, and be careful about the ones where the negatives might occur. And there's one other thing I wanted to note, and that is that when you see sine squared u, that means it's the sine u all squared. So sine u times sine u is equal to sine squared u. So looking through the page here that we already have worked on, we have all these identities. You can pause to check your work, and we're not responsible for the double angle formulas in number 5 and in number 10. We can take a look at number 7, 8, 9, and 10 there also. Just one more other reminder about this. Every once in a while, we do have to factor out a GCF. That's going to come up once in a while, and lots of work in getting common denominators. So let's move on to the next set of examples on the reverse of the page. We have to prove the following identities, and hopefully we work on either side and try and simplify them until they match. So let's start off with the first one. You split it down the middle, rewrite the left side using just the basic definition of cosecant, and then the right side you replace them both in terms of cos and sine, and we're going to have to simplify this expression. Now look for things that cancel, and make sure you can only cancel when they're multiplied, not when they're subtracted. So you cancel off the cos t's, and you're left with 1 over sine t. Life is good. Left side matches right side. Number 2. First, we're going to have to split the fraction because the cosine and the sine, there's no other way to simplify this. You can't cancel because of the minus sign, so we're going to split it into two separate fractions. Cos x over cos x, sine x over cos x subtracted, and then we can put cos x over cos x is going to be replaced as simply a 1 minus sine x over cos x. And you might recognize that already as 1 minus tan x. On the right hand side, it's going to match. Okay, for number 3, we have the left side. Let's take a look at that right away, and we can put that secant, we can rewrite as 1 over cos. Get a common denominator. 1 is becoming cos over cos, and then you can get cos A plus 1 over cos A. On the right side, a little bit uglier because we have a complex fraction to contend with. Sine squared A over cos squared A for the tan squared, and 1 over cos A minus 1. We're going to multiply by the reciprocal, but first we need to organize the bottom a little bit better. So we're going to get a common denominator there. And let's just skip a step here. It was going to look like that after you clean it. So we're going to multiply the top of the fraction by the reciprocal of the bottom of the fraction. Now what can we cancel? Well, you take a look at these and you say to yourself, okay, wait, I can get that one of the cos's is going to come out of there. You can't cancel straight up and down here because of the minus. So what we're going to do is going to put the cos A from the top is going to disappear, and one of the cos A's on the bottom. And cleaning that up, we're going to get just one cos A on the bottom. Now the sine squared A, this is not fitting anywhere. So we're going to have to use a trig identity, a Pythagorean identity, 1 minus cos squared A. And then we're left with cos A on the bottom here, 1 minus cos A on the bottom there. You want to cancel again, but you can't because the minus signs. You can't do anything. However, we have one more trick up our sleeve, and that is how to factor the difference of two squares. That a squared minus b squared, whatever, set up. So it's a difference of two squares, and we can do 1 plus cos A, 1 minus cos A. all over cos A. And in the second fraction, 1 minus cos A on the bottom. I'll put it in brackets to remind you that we can't cancel unless they're identical. So we cancel both those brackets, left with 1 plus cos A over cos A, which makes the left and right finally match. All right, so let's take a look at number 4. I think I see something here from the previous question that's going to make this work well. I'm going to rewrite that cos squared x as 1 minus sine squared x. And this should look a little bit familiar. We did something like this. You can't cancel right away. However, I have the difference of two squares up on top there, which is going to allow me to turn it into 1 plus sine x, 1 minus sine x. 1 minus sine x's are going to cancel. And then we're going to be left with just 1 plus sine x in the bottom. Looking pretty good. On the right-hand side, okay, we're going to have complex fraction on the bottom. So let's put the cos x over 1 right away. And the secant is 1 over cos. The tan is sine over cos. Thankfully, we have a common denominator. And so on the bottom of the bottom, we're going to have cos x and 1 minus sine x over that. And you multiply by the reciprocal. Okay, 1 minus sine x, but the other side has 1 plus sine x. Anyway, we'll put it together. Cos squared x over 1 minus sine x. And I'm about to start working about, hey, I can change this. But hold on a second. If you take a close look, the left side is already there. We've got the left side up here, cos squared x, 1 minus squared x, 1 minus sine x, and equals the right side. So no more work to do on that. In fact, we didn't even have to work out on the left side as we did. So we've got the two sides in number 5, and we want to make sure that we can clean these up. I'll do the multiplication first. It's going to be easier and give me a better idea of what I need to follow up with. So on the right, I've got cos over sine, cos squared over sine squared, times cos squared. Put those together, you're going to get cos to the 4u over sine squared u. Not looking like much, but at least I know what I'm heading for on the left. So rewriting cos squared, cotan squared is cos squared over sine squared times cos squared u. I want to add these together, so I'm going to need a common denominator. I'll multiply top and bottom by sine squared, and that should give me common denominator. And on the top, I'll have cos squared u minus cos squared u sine squared u, all over sine squared. You want to cancel this? You can't, all right, because of the minus. But we can do something a little ingenious, and this comes with a little bit of practice. We can take out a GCF from the top. And so that's going to take cos squared u out of there, leaving you with a 1 from that first term and a sine squared u from the second term, all over sine squared u. Now, you've got to recognize that 1 minus sine squared u is going to turn nicely into cos squared u again. And you're going to multiply the two of them together on top, which gives you cos to the 4u over sine squared u, and they match. Left side equals right side. Number 6, left side, sine A, cos A, not much to do there. Let's take a look at this complex fraction. Well, it will become a complex fraction. And so it's 1 plus tan A is going to become 1 plus sine A over cos A, and 1 over cos A for the denominator. And now get a common denominator up on top. So the 1 becomes cos A over cos A. You'll add those two together on the top, giving you cos A plus sine A over cos A. That's the top of the fraction. Now I'm going to multiply by the reciprocal of the denominator. I can cancel out those two cos A's, and it leaves me with just cos A plus sine A, which is exactly what I wanted at the beginning. So life is good. Left side equals right side. Okay, let's try this. A little bit of technical difficulty there. On number 7, we're going to be doing tan squared, cos squared, and rewrite that as the coses and sines, and you can cancel away the cos squareds on the left, giving you sine squared plus cos squared, which equals 1. On the right, 1 over sine squared is going to become um, cos squared x, sine squared x, 1 minus cos squared x over sine squared x. And you recognize that as sine squared x over sine squared x, and that's equal to 1. Left side equals right side. So we're good that way. Now, moving on. Cosecant of t is equal to 1 over sine t. And sine of t plus cos of t and cotan t is going to be, let me fix this. I have the, it's going to be equal to cos t times cos t over sine t. And that's going to be equal to sine t plus cos squared t over sine t. Now, I'm going to meet a common denominator here, so I'll multiply the first fraction by sine t top and bottom. Well, multiplying that on the bottom and multiplying it on the top, that becomes squared. And now we have on the top of the fraction sine squared t plus cos squared t, which is screaming out as one of those trig identities, over sine t. And sine squared t plus cos squared t is equal to 1. And now we have left side equals right side.